I'm Lauro Garza. I work for CPS Energy here in town. We just did our arc flash analysis, and we have some environments that have less than 2 for a cal rating. And so our gas department does plug-ins on 240, 120 meters. So just wanted your opinion on, do you think we should put them in arc flash if we're like at a 1.47 or just leave them in cotton?
Well, let's look directly at the standard. We have 2 standards that have 2 different numbers, and I believe it's C2 that says 2 calories is the exposure, and there's another standard that has 1.8. What's the one that has 1.8 as a standard? Is that 70? 1.2. What standard is that?
70.
70E. Okay, 70E limits the exposure of the employee in an arc flash at the skin to 1.2. That's your action level. The C2 has an exposure level of 2, so 2 calories per centimeter squared. So whatever you put on, if they're exposed to a flash, that equipment should limit their exposure to a second-degree burn, sunburn. So that's the beginning, right there of your question. And now it's more or less a humanity kind of a thing. Do you want to do it because it could be more? And is your calculation worst case event? You have a lot of decisions to make as an employer when you're right there at that threshold. What's the value of your program?
What? Just quick question. What is it? 480? No, it's 240. Chance of igniting clothing at 240 is so much zero that I would say absolutely don't worry about it. Calculations in 240 are almost useless. Unfortunately, they're overstated in almost every case. Does anybody here ever had a clothing ignition in 240 work arc flash? Anybody? I hadn't found one yet. It's overstated in 240. That's my personal opinion. I know there's some situations, if you have a 208 system that has 3-phase in the box and you can get the 3 phases going, totally different animal. But a regular 240 where you really only have 2 phases total, you don't have a full 3-phase 480 in the back as a supply, it's almost impossible to ignite clothing. There, I'd totally put them in a good leather glove or some kind of a Kevlar glove for cut resistance, and don't worry about those guys.
Everybody understands about that arc in a box, right? It's pretty thoroughly explained in a couple of standards, but arc in a box as opposed to arc out in the open air, you got 360-degree all the way around distribution of energy out in the air, which is where linemen on overhead work. But in the underground, when you're especially inside of a 3- or 4-sided box, it's all reflected and it's pushed out directly at you. And now you've got plasma involvement and some other things that normally wouldn't be there out in the open overhead lines. And if you look at the C2 standard and look at those estimated thermal energies, you'll see them very, very, very low for the same voltages outdoors as opposed to indoors in those indoor situations. And that's the reason why, that reflected energy.